unfortunately, I'm gonna be solving the physics AMS quiz for week 8. Tariq couldn't really do it this week, so I'll be subbing in. Anyways, this week's quiz is either way really easy, and it's all about very simple moment and the thing we already took in the periodic about light and diffraction. Anyways, let's begin. So the rod shown below is pivoted at O, so O is our pivot, and it's subjected to a couple of moments. The moment is 7.82 Newton meters, and the force 1 and force 2 is equal to 13.26 each. They are equal. So what do we call forces that are equal and going in opposite directions? They are a couple. Since they are a couple, we know that the formula for a couple is force times distance between forces. So here they want what is the length of the rod, which is the distance between the two forces, isn't it? It's this distance. So you do the moment, which is 7.82, equals to the force. You only take one force in couples, times the distance, and you find the distance to be 0.59. Moving on. Here we have a question asking you compare the magnitude of the torque. Now we took something last year that tells us if a force is going through the fulcrum, it is equal to 0. So F1 passes the fulcrum, so it is 0. Now we have F2 and F3. Here and here. This is the distance. Now what can we see about F3? It is coming at an angle, whereas F2 is perpendicular. So whenever we have an angle, we need to account for this angle by multiplying it by sine of the angle between them. When you multiply by sine of the angle, it's gonna reduce the force. So even if they're at the same distance, if it's at an angle, it's gonna be less. So the one that's at a perpendicular distance, you just do F2 times distance. You don't need to do sine of anything. It's just sine of 90, which is 1. So F2 is gonna be greater than F3. So it is F2 greater than F3 greater than F1. Moving on. So here we have a question. Two sound waves emit sound, and they have this wavelength and this amplitude. And when you place a microphone at a certain point in the room, it detects no sound from these sources. No sound means we have undergone destructive interference. So when we have destructive interference, you must know we need it to be not a whole number. It has to be a decimal. It has to be a fraction of something. So 0.5 or 2.5 works. It can't be 20, that's a whole number. It can't be 3, that's a whole number. You're going to say, okay, how do we know A isn't a whole number? Or, sorry, how do you know A isn't a decimal? Okay, but also, how do you know A isn't a whole number? Like, you have no way of proving that A is a decimal point, so you cannot choose it. It is not for sure a decimal. Moving on. So here we have, the rod of length 30 centimeters. This 30 centimeters means it is at a length of 0.3 meters. So let me change the color. From here to here is 0.3 meters. Now, we could see that we have two forces. They're acting in opposite directions at equal magnitude, right? Which means we have a couple. But this time we have a couple that is at an angle. So what do? We have to find the distance. You're gonna first draw a line. I'm gonna work with one because with the couples you only need one pair of force. You don't need the second. So if we know this is a right angle and the whole thing is 120. 120 minus 90 makes this angle 30, right? So we multiply 20 times sine 30, which gives us 10. Since it gives us 10, 10 is our force. So then you do 10 times 0.3, which is our distance between the forces. You get 3 Newton meter. And that is it. Moving on. Okay, so the change in direction of the propagation of waves is called diffraction, which means when it passes through an aperture or a gap, the waves change directions, which is called diffraction. Now the pattern formed when overlapping waves is due to the interference. Memorize these, they are definitions. Now they're telling you find the displacement of water at positions X and Y. Now we need to go and look at positions X and Y. Here you have position X, here you have position Y. What can you spot the difference between them? Here, position X is where 2 points overlap. So here you have constructive. They're overlapping, they're superposing on each other. Constructive. Whereas here, there's no overlapping. It's just one, so it's destructive. So whenever you have it constructive or whenever you see them overlapping, you will get the wavelength or whatever times 2 times, in our case it's 25 meters, so it's going to be 50, and whenever it's destructive it is 0, and that is it. Because they are 25 minus 25, which is 0, whereas in the first case it's 25 plus 25. Moving on. You have a monochromatic light source of wavelength 520 nanometers, this is our lambda, and the diffraction grating of length 1 centimeter, so it's 0.01 meter, and that it has 500 slits. They want the slit separation. To do that, you do the length of the grating and over the number of slits, so you do 0.01 divided by 500 slits. You're gonna get 2 times 10 power negative 5, which is basically 20 micrometers. Now, the angle with the horizontal, how do you do this? You're gonna do the distance d, which is 20 micrometers, 20 times, the formula is small d times sine of the angle alpha equals to m times wavelength. So 20 times, oh yeah, by the way, they want the 6th bright fringe. You're gonna do 20 times 10 power negative 6, of course, because you need it all in SI units, times the angle, which you don't know, so it's sine of alpha, we don't know that, equals 6 times the wavelength. Our wavelength was given to be 520 nanometers. So it's 520 times 10 power negative 9. Then, if you have a calculator with the calc button, just put it into your calculator. If you don't, you do shift sign of, what's it called? 6.52 or 520, 6 times, sorry, not point. 6 times 520 times 10 power negative 9 all over 20 times 10 power negative 6. You're gonna get the angle to be 8 point something that rounds up to 9. Moving on to our next part. Which of the following are true? The answers are all light passing through the gratings are coherent. Yes, that's how we know they superpose. And the bright fringes that are observed on the screen are due to the interference of light. Of course. And here, let's see why these are wrong. The light changes direction of propagation after the grating due to interference? No, it is due to diffraction. The dark fringes observed on the screen are due to diffraction? No, it's due to interference. The light passing through the diffraction grating slows down, does not change its speed after it passes through a diffraction grating. Moving on. Okay, so now you need to identify the sign of the torque. This one I can't really explain other than the fact you need to do a right hand rule, screwdriver rule, not the one we took with the 3 fingers last year. So this one, it's gonna, if you can tell, it's going this way, which is, oh yeah, by the way, if it's clockwise, it is negative. Counterclockwise, it is positive. So this one, you're going to see that it's going in the counterclockwise direction. F2 is going in the same direction as F1, so it is also, oh wait, sorry, these are both in the clockwise direction. And you're going to have F3 is passing through the pivot. what did I say? Passing through pivot equals 0. Now F4 is going in the counterclockwise direction. So F1, F2 are negative, and F4 is positive, and this is null, which means 0. Negative, negative, null, positive. Moving on. This is in the next question. Okay, here's our next question. To investigate the properties of light, a group of students conduct a double slit interference. Anyways, it doesn't really matter the question, we just need the thing. Anyways, is any information not placed in? No, all the information we need is placed in the diagram. Okay. So here, they want the fifth order bright fringe, and it's observed at a distance of 4.8 centimeters. So the fifth order bright fringe distance is 4.8 centimeters. Now, what can we do? We could do the trigonometry, right? So we know that the distance from here to here is, or to the central maximum, is 0.6 meters. They told you that the fifth order, so from here to the left, say here's the fifth order bright fringe, this distance here is 4.8 centimeters. Okay, 4.8 times 10 power negative 10, 2 meters, sorry. So if this is our, so this is also our distance, which is 4.8 times 10 power negative 2, and this is 0.6 meters. Now, we could use sine and we can use tangent to find the angle, this angle. So this angle, how can you relate it? So tan of alpha, right? Because you have opposite and you have adjacent, you don't have hypotenuse. You could find it, but you don't. We don't have to. So you do tan of alpha equals opposite over adjacent, which is 4.8 times 10 power negative 2 over 0.6 t. And then you get alpha is equal to, you do shift negative tan of this to get alpha, by the way, which is 4.6. Now, to get the wavelength of the light, you're just gonna do the distance between the slits, which is given to be 0.040 times 10 power negative 3, because you need it in meters, times the angle, or sine of the angle, which is sine of 4.6, equals to the wavelength, which we are trying to find, times 5, because it is the fifth order bright fringe. And then you should get an answer like this. Moving on to our next question. Okay, here you have another question where you have slits. Anyways, in the Young's double slit experiment, the following pattern, and we know that this question has been wrong for a few weeks, it's 3 bright fringes. Anyways, so if between 3 bright fringes it is 5.4, between each one it is 1.8. You do 5.4 divide by 3. You get 1.8. Anyways, that's the first part. Oh yeah, that's it. Anyways, if you decrease, if the slit separation is increased, what's gonna happen to the interference pattern? So we know that we have a formula that is y equals m lambda big D, which is distance between screen and this, over small d. Now, if you make the slit separation increase, if this increases, what's gonna happen to y? They are inversely proportional, so if this increases, y will decrease. So they get closer to each other. Moving on. Okay, so here you have 2 identical loudspeakers, then they're placed 2 meters apart, and they emit sound waves in phases at a frequency of 680 hertz. The microphone is positioned 2.50 meters from the speaker and 2 meters away from speaker Q. If speed of sound is 340, what type of interference does the microphone make? Now, to solve this question, it's really easy. You just need to listen. So you need to find the path difference between them. So you do distance 2, you need to do distance 2 minus distance 1. Our distance 2 is this, our distance 1 is this. So you get 2.5 minus 2 equals 0.5. Then you need to find your frequency. So to find frequency, you need to find your wavelength. Wavelength equals speed over frequency. So it is equal, when you put your numbers in, 340 divided by 680 is equal to 0.5. So then you have a formula that says it is path difference over wavelength equals m, because our formula is path difference equals lambda m, but we need to find m to know what type of interference. So it's 0.5 divided by 0.5 gives you 1. Since 1 is a whole number, it is constructive interference. If you got a decimal, it would be destructive. Moving on. Now, again, most of this quiz, by the way, is old material. This question, I think it's new, but like same concept. Anyways, you have a laser light that falls on a slit of width 100 micrometers. A diffraction pattern forms on the screen that's 3 meters behind the slit. The distance between the centers of the central bright fringe and the center of the first dark fringe is 13.5. By the way, it's not new, never mind. Anyways, so we know the formula is y equals m lambda d over small d. So it is gonna be y is, they told you it's 13.5 millimeters, and it's the central bright fringe and the center of the first like dark fringe. So you just like do 1, because so it is 1 times lambda is what we're trying to find, times they told you it is 3 meters behind the screen, and over this, which is 100 times 10 power negative 6, and 10 negative 6, and I accidentally forgot to do times 10 power negative 3 here. Please don't forget in the exam. You're gonna get lambda equals something around 450 nanometers. Anyways, the distance between the centers of the first and second minima to 1 decimal place is gonna be like the distance between the 0 and the first. Same distance. If the same source is used to decrease the distance between the two centers by half, the size of the slit should be. So listen, they're telling you they want to reduce this by half. They want to half it. So then this must double. So if this is divided by 2, this is times 2. So it says 100 times 2, which is 200 micrometers. Moving on. The phenomenon as that's associated with the spreading of waves is diffraction. This is the definition. We don't need to do anything with it. Anyways, the sign of the torque due to F1 is, again, this one you need to do screwdriver rule. F1 here is moving this way to reach the axis of rotation, which is clockwise, so it is negative. And now F2 is moving in this direction to reach the axis of rotation, which is counterclockwise, which is positive. Moving on. Now we need to calculate the net torque on the pivot. Now you have two forces, each of a magnitude of 5 both forces have the same magnitude, but they act at different distances. So I told you that the formula for the torque, this is tau, by the way, a Greek letter that represents torque, equals force times distance from the pivot times sine of alpha or theta, whatever. So this is 5 times 2 times sine 30. Which is gonna give us 5. And this is 5 times 4 times sine 30. The second one here. Which is gonna give us 10. And now we add them together because they are acting in the same direction. You're gonna say how? Look, this one needs to go like this to reach the fulcrum. This one needs to go like this. They're both moving in this direction, which is counterclockwise. So it's gonna equal 15 Newton meters because you need to add these two numbers. Moving on. We've done this question a million times. Anyways, the width of 10 fringes is 1.4 centimeters, which is 0.014 millimeters. Then you need to divide it by 10 again. So you're gonna get 1.4 times 10 power negative 3, because this is for 10 fringes, you need for 1. So it's 1.4 divided by, 1.4 times 10 negative 2 divided by 10. You're gonna get 1.4 times 10 power negative 3. 0.4 times 10 power negative 3. The slit separation and the slit screen distance. So it's y, which is given as this, 1.4 times 10 power negative 3 equals 1 times the wavelength. You're going to say, why is it 1? Because if this is for 10 fringes, we made it into 1 fringe. Anyways, times the distance to the screen, which is 2.2, all over 1.1 millimeters, so it's times 10 power negative 3. So our wavelength is equal to 700 nanometers. You're going to get on your calculator. Moving on. You have 400 You have 400 lines per millimeter. The angle between the 0 and the first order maximum is 14. We said that our formula is sine alpha or theta, doesn't matter, times d equals wavelength times m. So here we have d, we need to find it. So d is equal to 1 over the number of lines. So it's 1 over 400 times sine of angle 14 equals to the wavelength, which we're finding, times m is 1 because it's first and 0. So then you get lambda is equal to 605 nanometers. Moving on to our last question. Okay, yeah, this question's, anyways. Oh shoot, I actually forgot to put the answers. Anyways, it's okay. The laser light of 650 nanometer wavelength is incident on a diffractive grating. The second order spectral lines form an angle of 32.5. The distance between the two slits is... So we need to put the formula, so it's d times the sine of the theta, which is 32.5, equals 2, which is m, times the wavelength, which is 650, times 10 power negative 9. You're gonna get d equals to 2.41 times 10 power negative 6. So here our answer is 2.41. Moving on. The number of slits per centimeter is 1 over 2.41 times 10 power negative 6. Which is our answer in the first part. So 1 divided by our answer is going to give us something like 413,307 slits per centimeter. Or well, this is per meter, sorry. So times 10 power 2 also. So it's 1 divided by 2.41 times 10 power negative 6 times 10 power 2. Should be then 4149 or something like this. It doesn't matter really. It's like something like that you get. Anyways, that's it for today. We hope you understood everything. Have a great day. Bye.